always the most accurate, let's say, solution that is always the best one for the current situation. There are multiple factors that you have to consider when you are approaching problems. And I think also March Madness, I think last year or 2 years ago, the two professors who won March Madness, the predictions, they used a simple logistic regression classifier, a linear model. So it doesn't always have to be complex. So yeah. Yeah, and some other project ideas. I just looked my news channel last, I think yesterday. One thing that I saw by Michelle is she built a computer vision assisted wine recommendation engine. I thought it was really cool. So she can basically predict or can show you if you like wine, where to find it. It's just one example of a data science project. I really recommend you, maybe if you have enough time, working on a hobby project that is interesting to you, because that will also help you to learn the tools and get something for your resume that you can then later show off. And also I met Joel at PyData not too long ago in Chicago, and he had this, it's just a crazy idea, but he had this FizzBuzz and TensorFlow interview written up. Has anyone of you read this blog post? It was actually pretty popular. So what he did is, he wrote a fake interview. Do you know the FizzBuzz problem? It's a popular problem in coding interviews. So what they ask you is just to see if you can code or not. Hey, can you write me a program? If the number is divisible by 3, print fizz, and if it's divisible by 5, print buzz. And if it's divisible by 3 and 5, then print FizzBuzz. And he went with a TensorFlow, a neural network. He built with TensorFlow a neural network to make the prediction instead of just doing the if-else. It was just a fun blog post, but yeah, he got invited to talk at PyData. That would be one fun project, for example. I mean, just coming up with something creative. He learned, he didn't know TensorFlow before, so he learned TensorFlow during his blog post. And yeah, another one, met Jacob also. He built it's a different kind of project, an open source project for probabilistic models, Pomegranate. And it was pretty cool. I mean, I like this tool first because nothing like this was out there for Python yet. And secondly, in this talk, he applied it to an interesting example, Gossip Girl. Does anyone know Gossip Girl? I didn't know this. I thought supposed to be a popular TV show. There was some TV show where there was one gossip girl or guy, and until the last season you didn't know who it was. And he was watching it with his girlfriend before the season was over, and during the season he was doing predictions who it might be based on certain features. And he applied his probabilistic models basically to this project. It was just a fun thing to do, but I mean, this is also a great thing just to work on a fun project that is interesting, and then you can share it with the world. I mean, yeah, it can be a lot of insights can be gained by that. I mean, like learning how to use these tools, interpreting your data, but also communicating it. And yeah, this is basically in a nutshell why I think projects are important. It's really about learning the tools, but also getting something for your CV. And also just beyond the tools, it's really about showing that you're a creative person, that you have interesting ideas, and that you can also work independently on a project. And maybe also because, bless you, because tools are not the most important thing, but you need tools to get the job done at some point. And I'm not sure, how many of you have used Python or R before? So who uses Python? So the rest is R then, I suppose. No, I think there's always this question: what should I learn? What is better? And things like that. And I personally, I started with R maybe 7 years ago or something like that. And later I switched to Python, but not because Python is better. I just found it more convenient. But other people find other things more convenient. So I think there's no one is better than the other, because both are ultimately more, just tools that help you to get almost the same job done. And choose whatever you like, I think. Because companies are looking for both people who can program in R and people who can program in Python. And yeah, so one interesting code. I forgot where I got this. I wrote this myself at some point, but I think I didn't come up with it. So R is basically a programming language developed by statisticians for statisticians, and Python was developed by a computer scientist, and it can be used by programmers to apply statistical techniques. What I want to say is basically the syntax is just a little bit different. People from statistics may find R more helpful or more convenient, more natural, and more people from computer science may find Python more natural. And the thing is, R has been developed with statistics in mind, and I would say statistics was added to Python later at some point with packages like NumPy and SciPy. So it doesn't feel so natural because it's not embedded in Python, but it's almost as convenient. And I don't know why, but I just happen to prefer Python. And yeah. But these are just programming languages. So there are also some other tools that at some point you may want to look up or something. For example, Hadoop or Spark. Spark is probably more popular these days. Both are tools to do the heavy lifting on big data sets, like distributed computing, splitting your data sets across machines. And yeah, Spark is more, I think it's faster if you have a large memory available because it keeps more stuff in memory. Hadoop has the limit how much stuff it can keep in memory. But then also databases like MySQL, SQLite, like things, trivial things like that can be very helpful. And yeah, I just put scikit-learn in there because it's one of my favorite projects. I'm also contributing to scikit-learn. It's a machine learning package and has almost everything I need for machine learning except for deep learning. But for deep learning, you have other tools like Theano, TensorFlow, and I think they are adding TensorFlow is was developed by Google, written in C++ and CUDA, and has Python bindings. But I think they are also adding R bindings at some point. Yeah, and GitHub. How many people of you are on GitHub? Oh, that's already so many. That's really great because when I started, I hadn't heard of GitHub, and I think that is probably one of the most important things also for sharing your projects, or even though if you don't want to share them, also for yourself, just to work on them, just to keep track of your work and having some sort of version control. And for students, they have the student developer pack. So when you sign up for this, if you have an edu address, it's free, and you can have unlimited private repositories then, which is pretty great. So you don't have to, I mean, if you don't feel comfortable sharing things in an early stage, or if you're working in your lab and your lab doesn't want you to share work before it's published, you can have private repositories, but you can already set it up for later publication if you like. I did this just for one paper, for example, where I worked in a private repository. Then we had this paper out, and I was said, okay, now you can make it public. I just had to press one button, it was already there, and I didn't have to spend any time to move it from one thing to the other and things like that. And so in GitHub, just briefly for people who haven't heard of it, so GitHub is just, let's say, a platform that hosts your projects that are under Git version control. So Git is basically a tool. It was developed by the Linux person, Linus Torvalds. There are other version control systems like Subversion or Mercurial, and this is probably the most popular one, maybe because of GitHub, but also it has some nice advantages that other version control systems don't have. And how this basically works is you have a server and computers, and computers are basically the users or people who are working on it. So a project, what's important if you're working with Git is you have copies of your project in several places. So for example, if GitHub goes down or things like that, you still have everything local, you don't have to worry. Everyone has a copy of this. So if your computer crashes, the server has a copy, or if both of your computer crashes, there's one of it on the server. And usually you work with multiple people in teams, so if someone goes down, someone will have a version. So, and you can also work on it while you're on an airplane, if you like. So you don't need internet. But nowadays they have Wi-Fi on airplanes, so it doesn't count. But yeah, and each Git repository has also multiple versions of your code when you develop it over time. So if you make a mistake at some point, you can go back. Or if you, let's say you collect data, and then you notice later you changed something because there was a bug earlier, you can still go back and say, we changed it at this stage and now we get the different results because of that. You have basically a track record of your work. And it's also great for collaborating. We'll come to this in a second. And how this basically works is also kind of efficient, so it doesn't make really unnecessary copies of your file. So if you work with Git, but all that happens is you have a project and then there's one hidden folder, it's called .git. You don't even notice it, it's just there. And and in Git you have then different versions of your, let's say, code database or data database. And if the code doesn't change, it will make just a copy of this code. And this image is not completely correct, I would say. So I think what they wanted to show is if you have version 1 and you go up to, let's say, version 5, and version B doesn't change, what it means, what it symbolizes or should symbolize is that it's just a link to this previous one, because it would be wasteful to store both of them. But it's not completely correct, for example, that if you have C and make a change, you have C1. So I think what they say, you have a separate file then, but it's just storing the delta, the differences. So you don't have to store the whole file if you just change one line. You just store the information what you changed. So it's even more efficient than it looks like here. Yeah, and the typical Git flow or Git workflow is also through GitHub is you start, let's say, with your master branch, your code. Then you make some changes along the way. And if you work on a public project, you submit, let's say, a pull request. So you take this original project, you make changes, so it becomes a separate, different branch. Then you think you're finished, you make a pull request, and then you talk to people, maybe via GitHub, and they give you feedback, then you maybe improve changes. Hopefully you come up with a nice scroll, a nice finished project, and then you merge it back to the master branch. So you are not disturbing what's important here, the main project. So you don't have to be worried if you have, let's say, software out there and people are using the software and you don't want to mess with it while you're experimenting, you don't have to worry because it will be in a separate branch. And unless you want to have it back merged, nothing will happen to the original project. Yeah, and what's so useful about GitHub is especially that if you're managing projects, that you can have this issue tracker, different people can file issues and you can discuss them, you have the pull requests, and you can have the releases, and I just picked Scikit-learn because it's one of my favorite projects, and you see how many people are contributing, and I think contributing, if you have time, is also a great way, or a great way to spend time. When I was contributing to, for example, Scikit-learn, I learned a lot because I wrote some code, and people had opinions about my code, and it helped me really to polish it a little bit, make it efficient here and there, and you learn things that you wouldn't have learned if you would just work on your own. So people give you really good feedback there, or also in other projects, and just in general. Has anyone of you used Scikit-learn or contributed yet? No? No? Yeah, I mean, it's really, you can see, I mean, there are 764 issues. Issues doesn't mean bugs or something, there are a few bugs, but it also means like requests for improvements or things that need to be, or maybe can be changed to improve it. It doesn't mean that it has 764 bugs, so don't worry. Yeah. And by the way, version 0.18 is coming out maybe today. Yeah, and keeping up to date, so that's maybe the last section. So I think one thing is also important, that you just maybe want to keep up with what's out there in the world and what other people are doing, getting ideas, seeing what's trendy and discovering nice things, just keeping up to date. Personally, what I like to use is Reddit for some reason. So I usually use the machine learning, Python, data science, and datasets subreddit. So there's always cool stuff out there. I don't read all of it because the day only has 24 hours, but I read flag stuff for reading it later, and I can just see at one glance what's useful out there, or what's new, basically. Yeah, and I also use Twitter a lot, for example. I mean, I don't use Twitter for private stuff. I use it more for to connect with tech people. I don't know why, but for whatever reason, Twitter is really popular for tech people. It's, I think, I'm not sure how many are using Twitter. I think it's not cool anymore, right? It's maybe last generation social network stuff. But a lot of tech people are there. For example, I found this nice release of a new book out there. I mean, okay, it was on Hacker News to be fair. But most of the tech people are on Twitter, and you can get the news there if you're interested, if you follow the right people. And yeah, there are also other websites and stuff like that. I mean, News Combinator is usually more like anything related to computers, not particularly to data science. It's also useful sometimes. There's this nice GitHub repository. It is a collection of maybe 100 or 200 blogs, just the RSS feed. So just maybe if you're interested in other people's work, you can find a list of nice blogs there. And there's also this Google Plus group. I'm not sure about this one. I'm recorded here. I said that Twitter is maybe a tool from yesterday. Maybe this is even from before that. But what I mean is it's not that much used anymore. But it's still cool, maybe. Okay, that was about news, maybe resources or something. I think I've just, yeah. So here, just, I don't want to talk about something that I haven't used it because I really don't know how good other courses are, but I'm pretty sure there are other good courses out there. I'm just mentioning these two because these are ones that I took, and I can maybe vouch for them. Yeah, I took this Intro to Computer Science class when it was new. I think it's 4 years ago, but they are still on there. I just checked yesterday. So Intro to Computer Science, I forgot the name, but it's taught by a professor at Georgia Tech, I think. I mean, you're probably also taking classes here, but if you don't and have too much free time, this is a great course to learn Python. So you're building a search engine with Python, but also learning not only coding, but also basically basics of computer science. Yeah, in the popular machine learning class, I took it when it came out in 2013 by Andrew Ng. He's at Baidu right now. It's probably one of the best machine learning classes out there. There was one better one. This is a great class. I don't want to say anything bad about it, but there was one better, I found better, was by Pedro Domingos. I think it was also called Machine Learning. He's at Washington University. But they unfortunately took the videos down because they reformatted Coursera's, whatever, layout, and this didn't fit the layout, I think. It was more like classical lectures, like 45-minute lectures. That was my favorite class, though. But this is a really great one, too. And yeah, books I found very helpful. One is Coding the Matrix by Philip Klein. I think there was also a course related to that. And he teaches basically everything about linear algebra in Python, implementing it from scratch. Not just using NumPy, things like that. You really, I mean, you build a linear algebra library. You probably don't want to use it in the real world because it's not efficient, but it really helps you to understand also linear algebra, I think, beyond just the math notation, but also really applying it. And yeah, the data mining book, it's by Professor Tan, who's also teaching the data mining class. This book is way easier than his class. It's more, but it's great as an overview of all the different techniques from basic machine learning and also text mining and association rules.